Hello everybody, I am Yağız Uysal. I'm working at Akzonobel Kemipol as project engineer in Coil Coatings R&D laboratory. Today I will present you the study of effect of coating chemistry and substrate zinc layer thickness on corrosion performance of coil coated systems, an electrochemical impedance spectroscopy study on coated galvanized panels. Today I will start with a brief introduction, and then I will continue with our experimental design, and then I will explain you our results, and then I will conclude my presentation. Organic coatings are mainly used for protective and decorative purposes. After metals are coated in high-speed lines, they are wrapped as coil. Coil-coated metals is often considered more durable and more corrosion resistant since the metal is treated before it is cut and formed. Substrate is generally galvanized or aluminum, and it has very fast curing time, like 20-30 seconds, and it has thin coating layers such as 5 micron primer and 20 micron top coats. And the coil coated metal sheets have applications in almost every area of our daily life, including industrial facilities, building, and domestic appliances. In coil coating lines, metals are first cleaned and rinsed for the pretreatment section. After that, primer and top coat parts are located. And this is the general scheme of coil coating. Coil-coated metal, the blue one is the metal, then we have the zinc layer, pretreatment, primer, and the top coat. Metal corrosion is very important phenomena since long-term warranties are given in coil coating sector. Understand the corrosion behavior of the coil-coated panel is very crucial. In order to understand the corrosion behavior of coated metal, there are two traditional methods, which are outdoor exposure testing and accelerated laboratory testing. In outdoor exposure testing, we basically put the panels outside where the extreme environmental conditions exist. It has very long testing periods, such as 5 to 20 years, and it's an expensive method. And in accelerated laboratory testing, it includes substrate, humidity, and UV cabins, and it has medium testing periods, such as 1,000, 2,000 hours. And it's also expensive to operate and maintain the equipment. Another method is electrochemical impedance spectroscopy. It's based on the cathodic polarization of the coated metal panel. It has shorter testing periods, and it's a cost-effective method. Electrochemical impedance spectroscopy is a widely used technique to observe the degradation of the coatings with respect to corrosion mechanism, and it's fast and it's tree analysis, and it gives higher information than the DC techniques. This technique works on the principle of measuring alternating current and the frequency-dependent impedance responses by bringing the system out of balance with a small sinusoidal potential signal. Electrochemical impedance measurements provide information about the impedance of the painted metal system before corrosion starts, and by comparing the different systems, inference can be made about which one has more protective properties. Also, impedance values measured after any system has been corroded, it can provide more information about the corrosion mechanism that will occur while using the coating under field conditions. And if we continue with our experimental design, we use gamma interface 1010E model in our experiments, and this is our scheme for the experiments, and our sample work as a working electrode, and the sodium chloride water solution we use as electrolyte. Before starting the impedance measurements, it was needed to determine how long panel will wait inside the sodium chloride water solution. And to do so, when we are tested primer and polyester, and the primer and PVDF samples for different durations. It was decided to immerse the panels inside the solution for 24 hours. And this is our sample set. Firstly, we will look at the coil coating layer comparison in the electrochemical impedance spectroscopy, and then we will move on to top coats. We had three kinds of top coats: polyester, PVDF, and high durable polyester. We also have two different zinc layer amount, 102.75 grams for all these different top coats. We can start with the comparison of the no pretreatment metal, chromium-free pretreatment, and the chromium pretreatment. If we look at the body impedance graph of bare and the pretreated metals, the green one in a green line indicates the chromium pretreatment metal, and it has the highest impedance values at low frequencies. Moreover, it has a much more linear decreasing. These are the criteria shows that the sample has effective corrosion resistance. On the other hand, there are constant impedance values for chromium-free and the bare metal at low frequencies, and this behavior is generally seen by the coatings at later stage of complex corrosion mechanism. This complex corrosion mechanism is also seen in Nyquist plot, as shown in the blue and the red one, and also the difference in the chromium pretreatment one can be seen clearly when it's compared to the other ones. Chromium pretreatment one has the highest imaginary values and the largest diameter, and the higher imaginary values indicates the higher capacitance, and this leads to effective corrosion resistance. We can also analyze the body impedance graph of polyester top coats. 20 micron polyester top coat applied on the chromium-free pretreatment and the primer. Actually, we have already analyzed the effect of the pretreatment here in chromium-free pretreatment, and when it's compared to bare metal. When 5 micron primer applied to chromium-free pretreatment, we have a jump in the impedance value. It gives a better corrosion resistance. And moreover, if we apply 20 micron polyester top coat, impedance value reaching higher than the 10 to the 9 ohm. And if we look at the phase angle diagram of different layers, it can be seen that the bare metal and the chromium-free pretreatment metals have similar behavior. At higher frequencies, the graphs are starting to increase. This indicates the panels started to lose their protective function. However, primer and the top coated metals kept their linear behavior even in higher frequencies. We can say for that our samples have a high corrosion resistance. Here we can continue with our top coats. We have three kinds of resin: PVDF, polyester, and hydrogen polyester. All of them are treated with chromium-free pretreatment and primer, and they have zinc layer of 275 gram. All of the samples tested in this study are obtained from coil coating line. Panels are taken and measured in the spectroscopy, and then they are analyzed, they are tested in accelerated Substrate test cabin for 1 hour or 1000 hours. And here we can see the results of the here we can see the pictures of the panels after the Substrate test. And moreover, electrochemical impedance spectroscopy measurements are obtained after Substrate test again. In the graphs, the circle ones corresponds to the measurements before the accelerated test, and the diamond ones corresponds to the panel measurements after the Substrate test. If we look at the body impedance values, and it can be seen that the PVDF coating has the highest impedance value and the better linear decreasing, which we can simulate in the accelerated test. PVDF coating has the less amount of blister and the rust formation. And we can continue with the comparison of the polyester and high durable polyester. It was expected that high durable polyester coating would have a higher impedance value, but actually it is not. The reason for this behavior is that the high durable polyester coating contains red organic pigment. If we look at the result of the measurements of the panels after Substrate test, PVDF coating has higher impedance value again. We can actually make the same comparison of different resin with the zinc amount of 100 gram, and we have actually do this similar to zinc amount of 275 gram. PVDF coating has the highest impedance value, and actually which we can simulate it in the accelerated test methods. I mean, it has less blister and rust formation. And this is the body phase angle diagram of the all 6 samples. As I mentioned before, in phase angle graph, it's important that samples have minus 90-degree angle. And if you look at the results, 2 PVDF coating of zinc layer amount of 100 gram and 275 gram, they're reaching minus 90 degree in low frequencies compared to other ones. And polyester coatings are following the PVDF, and the other one, the hydrogen polyester are the last. And we can continue with the comparison of different zinc layer. Again, here we have 3 kinds of resin, polyester, PVDF, and hydrogen polyester, and we have 2 different amount, zinc layer amount, 100 and 275 grams, and so it makes 6 different data. And in the body impedance mode graph, we can actually see 5 of them. Actually, this is not 5. The highest one, the purple one, corresponds to 2 of the PVDF coating. I mean, the 2 of the PVDF coatings, 2 PVDF samples, the PVDF results are overlapping in the one. Actually, we have double checked this one, and the numbers are totally different, but in the graph they are overlapping. And still, PVDF coating have the highest impedance values than the others, but we do not see any differences between 2 zinc values. In the polyester comparison, zinc amount of 275 gram has higher impedance than the 100 gram, the pink one and the orange one. And if you look at the phase angle diagram, the pink one, the 275 gram of zinc layer, reaching 90 degree and in the lower frequencies, and have much more linear behavior. And if we compare the accelerated tests results, samples that contain zinc amount of 275, all the samples that contain zinc amount of 275 have better results. In polyester coatings, in polyester systems, we have 2 different samples of white gray and metallic gray color, and we have here chromium-free pretreatment. In the accelerated test, metallic gray colored polyester systems has more rust and rust formation and blister than the gray-white samples. And however, in the body impedance diagrams and body impedance measurements, metallic gray samples have higher impedance value. So we can say that the electrochemical impedance spectroscopy measurements could simulate the accelerated substrate test for the color comparison. We can also analyze the color differences in the samples with chromium pretreatment. Actually, the same comparison can be made with the chromium-free pretreatment. Electrochemical impedance spectroscopy measurements method in the electrochemical impedance spectroscopy method, there is no big difference between the metallic gray and the white gray ones, while there is a small differences in the accelerated methods. And I can conclude my presentation as the PVDF coated panels show the highest impedance value compared to polyester and hydrobel one, which we can simulate in the substrate test. Effect of using organic pigments in formula on corrosion performance was demonstrated in hydrobel polyester coating. Increase in the zinc layer thickness led to get higher corrosion resistance in polyester. However, we couldn't distinguish it in PVDF coating based on the electrochemical impedance spectroscopy measurements, while there is a small differences in accelerated substrate test. And for the future studies, same studies can be analyzed on aluminum substrate. And similar to comparison of 1000 hours substrate test results and the spectroscopy measurements, additional controls like 250 hours or maybe the other ones also can be examined in the electrochemical impedance spectroscopy also. And water absorption time and the spectroscopy model should be investigated based on the coating systems. Here are my references. And thank you for your attention.
Okay, thank you very much, Mr. Uysal. And it was very interesting presentation. But maybe some of the audience would like to hear what was the aim of this work, this study, and so on. Short explanation, and then I will expect also the questions from the audience.
Hello, Mr. Denizligil. First of all, I would like to thank you and the full organization team for this opportunity. Regarding your question, I would say that in coil coating system, the corrosion performance of the coatings are very important. And in order to understand the corrosion behavior of any coating system, and is very important if we do it in a shorter time. I mean, what I mean in a shorter time is shorter than the traditional methods. I mean, in any design or any modification of any system, when we do the design and the modification, I mean, to see the effect on the corrosion performance is very important. And in the traditional methods, we do it like 1,000 hours. In the accelerated one, in the outdoor testing, it takes some maybe years. In the accelerated one, it takes some months. I mean, the main aim of this study is to understand the corrosion behavior of the coatings in a much shorter times, like 1 day, 1 hour, 24 hours, 48 hours. I mean, I would like to say this.
Okay, I'm just waiting for a few seconds. If there is no additional question, then we
Maybe I can also add some new comments about the aim and the purpose. Also, I mean, in the presentation, I also talk about the tests before the accelerated. I mean, the measurements in the spectroscopy before the accelerated test, and also after the accelerated test. I mean, it was aimed to understand the mechanisms of the corrosion. Is also an important parameter for us.
Okay, is there a question from Fulya Gülmez? Why do you choose the zinc coating?
Actually, in coil coating lines, our customers took the metals and then apply a zinc coating, and then they treated the metal, and then we applied a primer and our top coats. So these panels are taken from the coil coating lines. So all the samples contain zinc coating and the pre-treatment.
Okay. If there is no more question, then thank you very much, Mr. Uysal. Actually, if there are additional question comes to the organization team, then you will get the mails of the questions, and then you can answer them. Thank you very much.
I also thank you.